tangent t?
Or tangent of 10t.
Oh, like this?
No, like 10, like the number.
Oh, 10 tangent t.
No, like tangent, and then inside of the tangent is 10t.
I got it.
So
Am I correct now?
yeah, inside is, yeah, just like that.
Perfect. Good. So since we know L'Hopital's rule, and when you plug in, you get 0 over 0, let's give it a shot with L'Hopital's rule. There are other ways in which I will manipulate the function a little bit. So let's try L'Hopital's rule first. So limit as t approaches 0. The numerator is secant squared 10t multiplied by the inner function, which is 10. And the denominator prime is cosine 2t times 2. This goes to 1, this goes to 1, so the answer is 5. Another option would be to manipulate the function. How will I do that? With sine 10t over cosine 10t multiplied by sine 2t. This is not a problem. So when limit as t approaches 0, so that's not a problem because this is approaching 1. And the sine 10t, remember 10t approaches 0, so I need a 10t in the denominator and a 10t to the numerator. And the same thing for 2t, I need a 2t and times the 2t. This will go to 1. This will go to 1. 10t over 2t is 5. Limit of 5 is 5. But the best is L'Hopital's rule in this case. Okay, I can see the test. Yay! Okay, I'm ready for next question. Anything?
I just a quick follow-up question
Yes,
about
yes.
L'Hopital's rule.
Yes.
When you're using that rule, it always seems to be like with a fraction.
It must be. It's a limit.
Is there ever a case where you have to use the quotient rule along with it, or is it just strictly L'Hopital's rule?
Inside the limit, you can only use L'Hopital's rule.
Okay.
When t approaches whatever, or x approaches whatever, it doesn't matter. If it's inside a limit, you will never differentiate using the quotient rule.
Thank you.
Thank you. Next question.
We do 10?
Yes, from the test?
Yeah.
You're saying number 10.
Yeah, about the tides.
Let's take a look. Yeah, you just have to differentiate and plug in. So we have d prime of t, which will be negative 5 sine 0.503 t minus 6.75. And multiply by the inner function prime, which is 0.503. So the simplified form will be this times this. So it's negative 152.5 sine of 0.503 t minus 6.75. And then in this formula, you will plug in 2, 6, 10, 12. Do you want me to find it?
No, that's fine. I got it.
Very good. Good. Next question. Anything else?
I'd like to go over number 13 on that practice test.
Yes.
It's question where you're using find the differential of the function, and the function given is y equals
Yep.
x squared sine of 8x.
Believe it or not, my computer allowed me to open that. So y equals x squared sine 8x. Very good. So we're asked to find dy, not y prime or dy over dx. No. We're asked to find dy. So in order to find dy, I'm on page 3. So dy will be 2x sine 8x plus x squared cosine 8x times 8 times dx. So that's dy. If you want to factor out 2x, you can. You don't have to. Sine 8x plus 4x cosine 8x dx. This is the differential of y.
Thank you.
Very good. Thank you, Mark. Any questions? Anything else?
I have another question on the differentials. When I was doing the homework, I got confused between the linearization versus the differential. If that makes sense.
They are the same. That
Okay,
was,
that's what I thought. I thought they were pretty much the same, but then I wasn't sure.
yeah, they are the same.
Okay, thank you.
Thank you. Use the same squiggling thing, so exactly the same idea. You're going to see this more in Calc 2 with Taylor series.
Okay.
Next question.
I think we might want to save this for last, but can we definitely go over the extra credit?
Yes, of course. Yes. I thought I was going to swim in questions today. And in fact, I have to pull questions out of you. Does that mean that we know it all? Or we haven't finished? Or what does it mean? So how do I take it?
I think it just means we're not very talkative.
Okay. Well, then you will have to listen to me more. I would rather listen to you more. Okay, so we're asked to find a cubic function. So obviously, this is the general form of a cubic function, and these are the unknowns. How many unknowns we have here? Or variables or parameters? Yes. How many equations do I have to come up with? I heard something, but I'm not sure what I heard.
4.
Thank you. So can anyone give us anything? So
D equals ax cubed bx squared plus cx.
So what are we doing?
So it would be D equals ax cubed. Would that work? And
No.
then the rest of it.
No. What are we trying to do? Let me read the question. Maybe not everyone can see the question. So let me read the question. Find a cubic function, and the general form of a cubic function is given to us, whose graph has horizontal tangents at the given points. So we need 4 equations.
Is it possible for you to find the derivative
I have to.
of them?
Okay, y prime equals 3ax squared plus 2bx plus c. Done. Next.
And then we find the second derivative, and then the third and the fourth.
What for? Why would I need this, the second and the third and the fourth? What for?
Because to find A.
But those values have nothing to do with any of these derivatives. I don't have any knowledge about what's happening with the second, the third, and the fourth. What should I set them equal to? I don't have any information. Nobody tells me anything about the second, the third, the fourth. What are the obvious equations? If a graph of a...
Would the two of the equations be where y is the y?
Of course,
y point?
of course, the points are on the graph. Absolutely. So negative 8a plus 4b minus 2c plus d, of course. Both points have to be on the graph of the function. And 2 equals 8a plus 4b plus 2c plus d, of course. How can a function have a tangent at a point that is not on the graph of the function? Of course. Very good. Next.
And then the other two would be the equation set to y, but with the x variable inserted. Would that be it?
Yes. So I have 4 times 3, which is 12a, and then minus 2b and plus c. And now what does that equal to? And again with 2, so that's 12a plus 2b plus c. But what do they equal to? Excellent. Thank you.
That'd be the derivative of y.
I did. But what exactly? I plugged them in the derivative of y, of the function, correct. But what are they equal to? Give it a shot. Anyone?
Is it 0?
Thank you very much. Horizontal tangent. What is the slope equal to for a horizontal tangent?
It's 0.
Of course. Excellent. Good. So we have a system with 4 variables and 4 equations. This old computer does not have the license so I can show you, but I will show you with the calculator, and if you cannot see it, you'll let me know. What I would like to show you is the inverse matrix method of solving a system. You can use substitution if you want to, but anyone can do that. And some elimination, blah, blah, blah. But I would like to show you the method of inverse matrix. It doesn't always work. If the matrix is not invertible, the method doesn't work. So first of all, I will create, so let me put the title here, inverse matrix. So the theory is that if I have a matrix A times the matrix of unknowns, and that equals B, and I will show how do we determine A, X, and B. If that's the situation, I can multiply on the left by A inverse, this matrix inverse, and that's what we're going to do. But I have to multiply on both sides. So if I choose to multiply, I have to multiply on the left-hand side on both sides of the equation. This becomes the identity matrix. So it goes away, in other words. So then X, the matrix of the unknowns, and I will explain what this means in a moment, will equal this. Okay, and now let's identify all these matrices. I need to identify matrix A, matrix X, and matrix B. These are column matrices, and this will be a 4 by 4 matrix. Okay, I don't have room here. So this is something from your past. Hopefully, maybe it will trigger your memory. If not, I think I'm on 4. Yes, I'm on 4. Let me see how I'm with the time here.